Hello dear students, welcome back to the lecture number 4 of gravitation. So my dear students, last time हमने पढ़ा था acceleration due to gravity and then variation of acceleration due to gravity with the height and depth. So today we'll be doing some questions on this, some NEET and JEE PYQs. लेकिन उससे पहले एक काम करेंगे हम, we will summarize all this acceleration due to gravity. Okay, so let's do that. So first and foremost, what's the equation for the acceleration due to gravity? ये g किसके बराबर होता है? It is equal to gm divided by r square, number one. Number second equation for the acceleration due to gravity is something like this. It is 4/3 pi multiplied by g into rho multiplied by r. All right, so these are two famous equations for the acceleration due to gravity. One is in terms of mass and radius of the planet, and second is in terms of density and radius of the planet. Okay, next हमारे पास जो है that is gh, acceleration due to gravity at height h. There are two equations for this. One equation is gm divided by r plus h whole square, or you can write it gm के बदले आप लिख सकते हैं gr square divided by denominator में आ जाएगा बेटा r plus h whole square. Okay, so this is the acceleration due to gravity at height h. ठीक, फिर हमने यहाँ पे एक स्पेशल केस लिखा था. If for example this h is very small compared to r, in that very case the acceleration due to gravity at height h becomes something like this. It is g multiplied by 1 minus 2h divided by r. We have discussed this equation in detail last time. ठीक है, then acceleration due to gravity at depth d, that is something like this. It is g multiplied by 1 minus d divided by r. Okay, तो यहाँ तक हमने पढ़ा था last time. So today what we are going to do is that we'll be doing the questions on this variation of acceleration due to gravity. Okay, so this is our question number 1. The question number 1 is like this. This has been asked in NEET 2020. तो क्वेश्चन है क्या? सबसे पहले आप क्वेश्चन पढ़िए आराम से. So this is body weighs 72 Newton on the surface of the earth. What is the gravitational force on it at a height equal to half the radius of the earth? All right, so it's something like this. Let's start with the equation, that is gh equals to g multiplied by r square divided by what? Divided by r plus h whole square, isn't it? ठीक है जी. So one thing is clear, and that is whatever will happen, the acceleration due to gravity will happen to the weight of the body. If the acceleration due to gravity, for example, becomes half, then the weight of the body also becomes half, simply because weight of a body is equal to mass into acceleration due to gravity. So let's try to calculate first of all acceleration due to gravity at this particular height. This is gr square divided by r. What about the height? At what height you are supposed to calculate? At height equal to half the radius, so that means h equals to r divided by 2. Now what is this in the denominator? ये आ जाएगा बेटा न्यूमरेटर में gr square divided by r plus r by 2 will be 3r divided by 2 whole square. This r square and r square will cancel, so gh comes out to be what? 3 square is 9, 2 square is 4. It will come out to be 4g divided by 9. This is the acceleration due to gravity at this height. Okay, which in turn implies that the weight of the body at height h will be equal to 4 by 9 multiplied by weight of the body on the surface of earth, that is w. And this w is given to us. Let's put the value here. 4 by 9 multiplied by what? 72. Now what it is? 9 1 9 8 8 into 4 is 32. So the answer comes out to be 32 Newton. So this is the answer to this question. I hope that this question is crystal clear to you. Okay, so the answer to this question is this 32 Newton, option number A. Let's move to question number 2. Let's try to solve another question here. So this is question number 2. The question number 2 is simply like this. So let's go through the question. First of all, imagine earth to be a solid sphere of mass m and radius r. If the value of acceleration due to gravity at depth d below the surface of earth is same as the value of acceleration due to gravity at height h, and is equal to g divided by 4, where g is the acceleration due to gravity on the surface of earth, the value of h by d is. Okay, so what is the question exactly? What's the question? The question is like this, that the acceleration due to gravity at height h is equal to the acceleration due to gravity at depth d, and what you are supposed to calculate is the value of h by d. देख ले बेटा. So first and foremost, I will write down this equation. GH is equal to G multiplied by R square divided by R plus H whole square, isn't it? Now what's the value of GH that is given to you? That is G divided by 4 is equal to GR square divided by R plus H whole square, isn't it? This G and G will cancel, take root on both sides. This will be something like 1 by 2 equals to R divided by R plus H. From here we can easily calculate the value of H. So R plus H becomes equal to twice R. 1 R and 1 R will cancel. So H is equal to R. So this is the value of the H, that is R. All right. So this is the value of the H, that's equal to R. Now let's put the equation for this GD. What is the acceleration due to gravity at depth D? Acceleration due to gravity at depth D becomes G multiplied by 1 minus D by R. All right. Okay, again it's given that it's equal to G divided by 4. So let it be G by 4, G multiplied by 1 minus D by R. This G and G will cancel. 1 by 4 comes out to be what? It comes out to be 1 minus D by R. From this equation, let's try to calculate the value of this D. So D by R will be equal to 1 minus 1 by 4 क्रॉस मल्टीप्लाई करके आ जाएगा बेटा ये 3 by 4. जब ये 3 by 4 निकला, so D will be equal to what? It will be equal to 3R divided by 4. So we have calculated both height as well as the depth, at which the acceleration due to gravity becomes equal to G divided by 4. We have calculated both the values. We calculate the value of H and we also calculate the value of this D as well. Okay, so the value of H is this, which is H divided by H is equal to R, and this is the value of this D, which is 3R divided by 4. Okay, now what is the question finally? The question is finally calculate the value of H by D. Now it can be easily done. We divide the two, H by D, it will be simply equal to R divided by R, and R is going to cancel. 1 divided by 3 by 4. Now the reciprocal of this is simply 4 divided by 3. Now have a look at the options. Option number A is the correct answer. Okay, hope that this question is also crystal clear to you. This question was asked in NEET 2017. Let's move to another question. So next question जो है बेटा, that is the weight of the body on the surface of earth is given, that's equal to 200 Newton, and we are supposed to calculate what will be the weight of the body at the halfway down to the center. Halfway down to the center implies that what is given to you is that W is equal to 200 Newton, which is the weight of the body on the surface, and you are supposed to calculate the weight at the depth D, why this D is equal to R divided by 2. So easily we can use this equation that WD is equal to W multiplied by 1 minus D by R. Now it will be equal to W into 1 minus, what is this D? It is equal to R by 2. So D by R is obviously equal to 1 by 2. Let's put the value of W, that is 200. 1 minus 1 by 2 is 1 by 2. 200 divided by 2 is 100 Newton will be the answer to this question. Okay, so 100 Newton. Hope that this is also clear to you. Let's move to another question. Question number 4. You are supposed to calculate the weight or the gravitational force on the body. See, have a look. A body weighs 48 Newton on the surface of the earth. The gravitational force experienced by the body due to the earth at a height equal to 1/3 the radius of the earth. Simply it implies that what is given is that W is given 48 Newton. All right. H is given, it is equal to R divided by 3. The question here is calculate acceleration due to gravity or calculate W. We are supposed to calculate W at what height? We'll have to calculate WH at a height H equals to R divided by 3. So simply we will use this equation that GH, or for that matter I can write down WH equal to W R square, GR square के बदले मैंने लिखा WR square divided by R plus H whole square. Just put the value of H here and play with this equation. You will get the answer to this question. So this I will keep as a home assignment for you people. So my dear students, question number 6 for you. This is a JEE 2024 question, and what's the question exactly? It's like this, that mass of the body here is given. Let me write down the data first and foremost. The mass of the body is given, that is equal to 90 kilogram, number 1. Number 2, it's placed at 2R distance from the surface of earth, which implies that H is equal to twice R. experience a gravitational pull off, you will have to calculate what is the gravitational force. That means you will have to calculate WH at this very point. Okay, can we do this? Easily we can do it. So WH will be equal to what? It is equal to W into R square divided by R plus H whole square, isn't it? Okay, now what I will do is that इस W के बदले instead of this W I will write down M into G, लिख सकते हैं ना। तो यहाँ पे आ जाएगा बेटा R स्क्वायर डिवाइड बाई यहाँ पे आएगा R प्लस H के बदले हम लिख सकते हैं 2R होल स्क्वायर। ऑल राइट, so this will be equal to mg. Let me write down mg multiplied by r square. In the denominator there will be 2r plus r, 2r plus r, so that's equal to 3r. 3r whole square is what? That is 9r square. R square and r square will cancel. WH जो आएगा बेटा that is mg divided by 9. सही है ना, mg divided by 9. Now what is the value of m? Let's put that here. That is 90 into 10 divided by 9. The answer comes out to be 100 Newton will be the answer to this question. Okay, so that is part D, option number D. Okay, so hope that this question is also crystal clear. Let's move to another question. Question number 7, an important question and has been asked in the JEE Main 2024. It is sort of simple pendulum and simple pendulum in gravity. Okay, it's like that. The first thing I will write down is that let's first of all go through the question. तो देख लें बेटा आप क्वेश्चन में क्या दिया गया है। सिंपल पेंडुलम परफॉर्मिंग स्मॉल ऑसिलेशंस एट हाइट और above the earth's surface has time period t1 which is equal to 4 seconds. What would be its time period t2 if it is brought to a point at a height 2 or from the earth's surface? All right, let's do one thing first and foremost. Let's try to calculate what's the acceleration due to gravity at height h equal to r and at height h equal to r. Okay, I will tell you a trick, simple direct method how to calculate acceleration due to gravity at any height h. Okay, I will write down the equation something like this, that if h is equal to n times r, then in that very case acceleration due to gravity at height h will be ये होगा बेटा g divided by n plus 1 whole square. So इस इक्वेशन से आप डायरेक्टली कैलकुलेट कर सकते हैं कि एक्सेलरेशन ड्यू टू ग्रेविटी किस हाइट पे क्या है, व्हाट इज द वैल्यू ऑफ एक्सेलरेशन ड्यू टू ग्रेविटी एट एनी पर्टिकुलर हाइट। ठीक है जी, तो यहाँ पे जो इस क्वेश्चन में h1 दिया गया है दैट्स इक्वल टू r। आप देख लो क्वेश्चन, आप देख लें बेटा क्वेश्चन। सो एट ए हाइट r from the earth's surface, then at a height of 2 or from the earth's surface. Let's first and foremost calculate these two values. h1 is equal to r, which implies that g1 जो आएगा बेटा that will be equal to what? That will be 1 plus 1 is 2, 2 square is 4, तो ये आ जाएगा बेटा g divided by 4. h2 is given to me, that's equal to twice r. What about this g2? It will be equal to g divided by 2 plus 1 is 3, 3 square is 9. So we have calculated what is the value of acceleration due to gravity at the two different heights. Now the question is like this, that if the time period of the simple pendulum at height h1 is 4 seconds, then the time period at this height is t2, that is t2 at some height h2, and we will have to find what is the relation between t1 and t2. Okay, so next thing you should know is that next चीज जो आपको पता होनी चाहिए वो ये है कि what is the time period of the simple pendulum. So time period of simple pendulum अगर आपको याद होगा बेटा that is 2 pi square root of L divided by G. We'll study this in detail in simple harmonic motion, लेकिन कम से कम units and dimensions में तो ये सीखा होगा that time period of simple pendulum होता है 2 pi square root of L divided by G. Can I write it like this, that it is inversely proportional to acceleration due to gravity, isn't it? Can I write like this? Which means that t1 divided by t2 should be equal to something like this, square root of g2 divided by g1, because it is inversely proportional to square root of g, isn't it? Now we have calculated the values of this acceleration due to gravity. We have calculated g2 and we have calculated g1. Let's put the values here. What is the value of this g2? That is equal to g divided by 9. And what about this g1? That is g divided by 4. So g and g will cancel. Square root of 9 is 3. Square root of 4 is 2. On solving, this will come out to be 2 by 3. Isn't it? Which implies that this 3 times t1 is equal to 2 times t2. Okay? Isn't it? because this equation implies that this T1 by T2 should be exactly equal to 2 by 3. So when it's 2 by 3, so that means 3T1 equals to 2T2. So this is the answer to this question. That is option number C. I hope that this is clear to you. What I have done is that I have calculated acceleration due to gravity at height h equal to r, then at a height h equal to twice r, and then I have written down what is the time period of the simple pendulum, and then see how it is related to the acceleration due to gravity. Then t1 divided by t2 will be square root of g2 by g1. On solving this, we get something like 2 divided by 3, which implies that this is the relation between the t1 and t2. Let's move to another question, my dear students. So this is question number 9. सी दैट एक बात मैं आपको बता दूं दैट जब आपने पहले बेसिक्स पढ़ा है देन द क्वेश्चन सॉल्विंग इज एज इम्पॉर्टेंट एज द कॉन्सेप्ट्स. दे आर रियली हाईली इम्पॉर्टेंट. तो वंस यू आर डन विद द कॉन्सेप्ट्स, वंस आपने बेसिक्स अच्छे से क्लियर किए हैं, द नेक्स्ट थिंग यू विल हैव टू डू इज दैट डू एज मैनी क्वेश्चंस एज यू कैन and write down as many tests as you can. Okay, because you will learn from after on practicing these questions, you will learn from these questions. You will commit mistakes, but you will learn from those mistakes. Okay, so my dear students, let's try to do the question number 9. The question number 9 is what we call as the reason assertion type question. Okay, so assertion that in this question is given that is time period of a simple pendulum is longer at the top of the mountain than that at the base of the mountain, and reason is given that time period of simple pendulum decreases with the increasing value of acceleration due to gravity and vice versa. देख ले बेटा, simple, first and foremost you should know what's the time period of the simple pendulum. The first thing is that time period of simple pendulum is inversely proportional acceleration due to gravity. This is important for us. Okay, now time period of a simple pendulum is longer at the top of mountain. As you move away from the surface of earth, as you go upwards from the surface of earth, the acceleration due to gravity decreases. When the acceleration due to gravity decreases, that means the time period should increase. Acceleration due to gravity will decrease, so time period should increase. The question is like this, that the time period of simple pendulum is longer at the top of mountain, so it is obviously true. So that means the assertion is true. All right, फिर आप reason देख ले बेटा. Time period of simple pendulum decreases with the increasing value of the acceleration due to gravity. As the acceleration due to gravity increases, the time period decreases. All right, so both the statements are correct. Both the statements are correct, and this reason is the correct explanation of the assertion, because it is given the assertion that time period of simple pendulum is longer at the top of Mount Everest. As you move in the upward direction, the acceleration due to gravity decreases, hence time period increases, and time period of simple pendulum is decreases with the increasing value of acceleration due to gravity. So that means both the statements are correct, and that तो इसका जो आंसर है both A and R are correct, and R is the correct explanation of A. Let's move to another question, question number 10. देख ले बेटा, question number 10 में दिया क्या गया है, we will have to calculate at what height the acceleration due to gravity, the height in terms of radius of earth at which acceleration due to gravity becomes g divided by 9. Okay, so my dear students, let's try to solve this. This question is asked in JEE Man 2026. So acceleration due to gravity at height h is something like this. It is gr square divided by r plus h whole square. ठीक है जी. Now gh दिया गया है किसके बराबर है, that is equal to g divided by 9, which is g multiplied by r square divided by r plus h whole square. This g and g will disappear. We will have an equation something like this, 1 by 9 equals to r square divided by r plus h whole square. Let's take square root on both sides. This will be something like 1 by 3 equals to r divided by r plus h, because square root of 1 होता है बेटा 1 and square root of 9 is equal to 3. Let's go for the cross multiplication. तो equation आपके पास आ जाएगी r plus h equals to 3r, which implies that h is equal to 2r. Okay, now this question, this type of question is asked every now and then in the NEET and JEE mains. So why not to do one thing is that I will show shortcut trick to this question. एक तो मैंने proper physics apply करके मैंने ये question आपको दिखाया, तो इसका जो आंसर निकला that's equal to twice r. So that means B part is the correct answer to this question. Okay, now why not to do one thing, that is let's have a shortcut trick for this. तो इसके लिए जो शॉर्टकट ट्रिक है वो कुछ ऐसे हैं, दैट्स लाइक दिस, लेट मी शो द शॉर्टकट ट्रिक हियर। ठीक है जी, तो शॉर्टकट ट्रिक ये है, अगर ये h होगा, इफ दिस जी एच इज इक्वल टू g डिवाइड बाई n, जिस तरह यहाँ पे है g/9 where n is equal to 9. So if gh is equal to g/n, we are supposed to calculate value of h always comes out to be square root of n minus 1 multiplied by r, a very important equation, handy equation. Okay, अब आप देख लें बेटा, अगर आप क्वेश्चन नंबर 10 में देखोगे तो एक्सेलरेशन ड्यू टू ग्रेविटी दिया गया, दैट्स इक्वल g डिवाइड बाय 9. So what is the value of n here? N is equal to 9, which means that the height will be equal to square root of 9 minus 1 multiplied by r. Now tell me one thing, my dear students, what is this root 9 equal to? It is 3. 3 minus 1 is equal to 2. तो क्या आ जाएगा बेटा? It will come out to be twice r. Simple. Isn't it very simple? यहाँ पे देख लो आप, जो आपने इससे पहले प्रोसीजर लगाया, गुड अमाउंट ऑफ मैथमेटिक्स वॉज देयर. ओके, तो सॉल्व करने के बाद आंसर निकला था h इक्वल टू r. नाउ यू कैन अप्लाई दिस शॉर्टकट ट्रिक एंड विद नो टाइम you can calculate what is the answer to this question. Okay, let's move to another question. That's question number 11. Question number 11 जो है, it also belongs to that simple pendulum. Okay, so it is simple pendulum plus gravitation. अब आप देख लें बेटा क्वेश्चन है क्या. Assume there are two identical simple pendulum clocks. Clock 1 is placed on the earth and clock 2 is placed on a space station located at height h above the surface of earth. Clock 1 and clock 2 operate with a time period of 4 seconds and 6 seconds respectively. Then the value of h is. देख लें बेटा आप क्वेश्चन है क्या. So first and foremost, I will write down one equation, that is this time period of simple pendulum is inversely proportional to acceleration due to gravity, isn't it? Now next I am going to write down is this, that this t1 divided by t2 will be equal to something like this. It is equal to g2 divided by g1. all right, and clock 1 जो है बेटा, clock 1 that is on the surface of earth. okay, so that means g1 is simply equal to, it is equal to g, and g2 is equal to what? It is equal to gh. okay, then it is given, then the time periods are given. Now what's t1 and t2? T1 is given, that's equal to 4 divided by t2 is given, that's equal to 6. So this is here, I can write it like this. It is equal to square root of what? gh divided by g. okay, let's do one thing, squaring both sides. So 4 square is equal, or I can write it like this. I can write like this, 2 by 3 equals to gh divided by g. all right, whole square. ओके, 2 2s are 4, 2 3s are 6. तो ये जो बन जाएगा, इट विल बी 4 डिवाइडेड बाई 9 इज इक्वल टू जी एच डिवाइडेड बाई जी. ओके, नाउ फाइनली वी आर हियर दैट जी एच जो आएगा बेटा, दैट कम्स आउट टू बी 4/9 मल्टीप्लाइड बाई जी, एंड वी विल हैव टू कैलकुलेट द वैल्यू ऑफ एच. इज दैट क्लियर टू यू? वी विल हैव टू कैलकुलेट द वैल्यू ऑफ एच. सो ईजिली वी कैन कैलकुलेट दैट. नंबर 1 इस जी एच के बदले आप लिख सकते हैं जी आर स्क्वायर डिवाइडेड बाई आर प्लस एच होल स्क्वायर कम्स आउट बी व्हाट? 4 डिवाइडेड बाई 9 मल्टीप्लाइड बाई जी. दिस जी and g will cancel, take square root on both sides, we'll get an equation something like this, r by r plus h equals square root of 4 is 2 and square root of 9 is 3. Go for the cross multiplication, 3r is equal to 2r plus 2h. So 3r minus 2r is r, तो h जो आएगा बेटा, that will be equal to r divided by 2. Now r by 2 is exactly, now this r is equal to 6400 kilometers divided by 2. 6400 divided by 2 comes out to be exactly 3200 kilometers. So at this height. Okay, so 3200 kilometers is the answer to this question. Okay, let's switch to another question. So question number next has been asked in JEE Man 2022. Let's try to solve this question. तो सबसे पहले आप क्वेश्चन देख लें बेटा. If the acceleration due to gravity experienced by a point mass at height h above the surface of earth is same as the acceleration due to gravity at depth d, then d is given, it's equal to alpha multiplied by h from the earth's surface, then the value of alpha will be. Okay, but it is given that h is very small compared to r. Okay, so देख लें बेटा आप. I will write down first of all like this, that is acceleration due to gravity at height h is equal to acceleration due to gravity at depth d. It is given to you. And then one important thing is mentioned, that this height is very, very small compared to r. That means for the acceleration due to gravity at height h, we will use the second equation. And what is that? That is g into 1 minus 2h divided by r, isn't it? And this gd will be equal to g into 1 minus d divided by r. Now see, in this equation, this g and g will cancel, this 1 and 1 will cancel, this minus and minus will cancel, this r and r will cancel, and we are left with only this thing, that this twice h is equal to, that is equal to d. Okay, now अब आप देख लें बेटा, यहाँ पे दिया गया that this d is equal to alpha h, so d is equal to twice h in turn equal to alpha h, implies that the value of this alpha is equal to 2. So the value of alpha is equal to 2. Okay, hope that it's crystal clear to you. Let's move to another question. तो नेक्स्ट क्वेश्चन जो है बेटा वो ये है, दैट वेट ऑफ बॉडी ऑन द अर्थ इज 400 न्यूटन, देन द वेट ऑफ बॉडी व्हेन टेकन टू डेप्थ हाफ ऑफ द रेडियस ऑफ द अर्थ. देख ले बेटा, आई विल राइट डाउन, आई विल गिव सम हिंट एंड यू विल डू दिस क्वेश्चन योरसेल्फ. GD is equal to G into 1 minus D divided by R, which can be also written like this, WD is equal to W into 1 minus D divided by R. Okay, then what is given is W is given, that's equal to 400. This W is equal to 400 Newton, and D is equal to R divided by 2. Now put these two values here, you can get the value of WD. WD will be 400 into 1 minus, from here D by R is equal to 1 by 2. 1 minus 1 by 2 is 1 by 2. 400 by 2 is 200 Newton. So 200 Newton will be the answer. Okay. Question number 17 is a direct question. You will have to calculate acceleration due to gravity at height h, for h very, very small compared to r. So this is the answer to this question. Question number 18 देख ले बेटा आप. Rotation of the earth shows effect on the value of acceleration due to gravity. Yes, it shows. Acceleration due to gravity does depend upon the rotation. अभी हमने वो डिस्कस नहीं किया है, but at least we know this, that the acceleration due to gravity does depend upon the rotation of earth. Statement second is like this, that the effect of rotation on the earth on the value of the acceleration due to gravity at equator is minimum, and that on the pole is maximum. It is absolutely incorrect. Acceleration due to gravity और rotation जो है बेटा, rotation का effect होता है on acceleration due to gravity at equator, that is maximum, and that is 0 at the poles. So that means the first statement is correct and the second statement is false. तो इसका जो आंसर आ जाएगा बेटा वो है statement first is true and statement second is false. तो ये इसका आंसर है. ठीक है बेटा. Okay, another question we have. The question has been asked in NEET 2017. What is the question? Is that acceleration due to gravity at height 1 kilometer above the surface, above the earth, is same as the acceleration due to gravity at depth d below the surface of earth, then d is equal to, simple, very simple. It's like this, that it is given that GH equals to GD, it is given to me. Then GH is equal to G into 1 minus 2H divided by R, and GD भी हमें पता है बेटा, that is G into 1 minus D divided by R. From here you can easily write down that this 2H is equal to D. Now the value of H is given, that is 1 kilometer. So 2 multiplied by 1 is equal to D, which implies D equals to 2 kilometers. Okay, so this is the answer. So the important equation here, one more, is that if GH is equal to GD, GD is equal to GH for H very, very small compared to R, in that very case the relation between the H and D is something like this, 2H equals to D. Okay, let's move to another question. This question is a NEET 2020 question. What is the depth at which the value of acceleration due to gravity becomes 1 by n times the value at the surface of earth? An easy question. Let's write down the acceleration due to gravity at the depth d. What is that? That is G into 1 minus d divided by R. Okay. Then what is the depth at which the acceleration due to gravity becomes 1 by n? Then it is given that GD is equal to G divided by n. It is given in the question, G into 1 minus d divided by R. G and G will cancel obviously. 1 by n will be equal to 1 minus d by R. We are in search of d. So let me write down here d by r equals to 1 minus 1 by n. Go for the cross multiplication, it is n minus 1 divided by n. तो यहाँ पे जो d आएगा बेटा दैट विल बी इक्वल टू व्हाट, दैट विल बी n माइनस 1 इंटू आर डिवाइडेड बाई n. So this is the depth, this is the depth d at which the acceleration due to gravity becomes equal to what, that becomes equal to g divided by n. Okay, all right people, let's move to another question. Another question is like this, that a body of mass 60 gram, it is given to you, experience a gravitational force of 3 Newton when placed at a particular point. The magnitude of gravitational field intensity. एक बात आप याद रख लें बेटा, जो एक्सेलरेशन ड्यू टू ग्रेविटी है या ग्रेविटेशनल फील्ड डिनोटेड बाय EG, they are exactly same in magnitude and both are equal to what, both are equal to gravitational force divided by mass. Now in the question, the gravitational force is given to you, that is 3 divided by mass of the particle is given, that is 60 gram. 60 gram means I can write it like this, 60 divided by 1000 kg. This is here Newton, isn't it? Okay, so g or gravitational field, acceleration due to gravity or gravitational field will be equal to 3 into 1000 divided by 60. This and this will cancel, this is 3 1 3 2, so 100 by 2 comes out to be exactly 50 Newton per kg. So 50 Newton per kg is the answer to this question. Easy question. Question number 7 है बेटा, that is these physical quantities are given to you, A, B, C, D, and dimensional formulae are given, and you will have to match the physical quantity with the dimensional formulae. All right, first and foremost there is gravitational constant. Gravitational constant g जो है इसका डायमेंशनल फार्मूला होता है m-1 L3t minus 2, which implies A matches with the second. So A with the second, all right, A with the second. Then gravitational potential energy U, it is simply potential energy, इसका यूनिट होता है जूल. डायमेंशनल फार्मूला होता है इसका m1 L2t minus 2, which means that A with the second, so A matches with the second, and B with the fourth. अब options देख लें, A with the second, B with fourth. So again there are two more options. Let's go to the C, that's gravitational potential. Gravitational potential is simply, it is potential energy per unit mass, so it will be equal to L2t minus 2. So that means L2t minus 2, gravitational potential L2t minus 2, it will match with the first. All right, and then we are left with only this gravitational intensity whose dimensional formula is same as that of acceleration, that is L1t minus 2. So that means इसका जो आंसर आ जाएगा, that is A with the second, B with the fourth, A with second, B with the fourth, C with first. So option number A is the correct answer. Let's move to another question my dear students, that is question number 29. and question number 29 में पूछा क्या गया है, फिर से सिंपल पेंडुलम वाला क्वेश्चन है. Simple pendulum is placed at a place where its distance from the earth's surface is equal to the radius of earth. That means h is given to me, that's equal to r. When h is given to me, that's equal to r, let me calculate what's the acceleration due to gravity first and foremost. That is g divided by n plus 1 whole square, and n here that's equal to 1, तो ये आ जाएगा बेटा g by 1 plus 1 whole square, that is 2 square, that comes out to be g by 4 is the value of acceleration due to gravity. Okay, if the length of the string is 4 meters, then it is given to you that the length of the string is 4 meters. Great, perfect. Then the time period of the small oscillations will be, we will have to calculate what is the time period, and it is given that this g is equal to pi square. It is mentioned in the question. So it is very simple. Let's write down the equation for the time period of a simple pendulum, that is 2 pi square root of L divided by g. ठीक है जी, तो टाइम पीरियड आएगा ट्वाइस पाई इंटू रूट ऑफ 4 डिवाइडेड बाई root of g is given that it's pi square. All right, it will be something like this, 2 pi multiplied by 2 divided by pi. Pi and pi will cancel, 2 into 2 is 4 second. So this is the answer to this question, it is 4 seconds. All right, my dear students, so the answer is 4 seconds, but here we don't have any option. What is the problem with this? तो सबसे पहले हमने तो एक्सेलरेशन ड्यू टू ग्रेविटी, ओ वेट अ मोमेंट, यहाँ पे थोड़ा सा एरर आ गया बेटा। तो यहाँ पे जो एक्सेलरेशन ड्यू टू ग्रेविटी है दैट इज GH, सॉरी, which is equal to this, GH is equal to G by 4, we have calculated that. So that means this is something like pi square divided by 4, pi square by 4, okay. So what will cancel is this, यहाँ पे आ जाएगा बेटा pi by 2 instead of pi. This pi and pi will cancel, 2 into 2 into 2, that is not 4 second, that is 8 second, that's 8 second. सॉरी बेटा, यहाँ पे थोड़ा सा एरर हुआ, तो यहाँ पे आंसर आ जाएगा, that will come out to be 8 seconds. So this is the answer to this question. Okay, my dear students, question number 30 is there. What is question number 30? To be exact is this: assuming that the earth to be a sphere of uniform mass density, a body weighs 300 Newton on the surface of the earth, how much would it weigh at a depth r by 4 below the surface of earth? That means again you will have to calculate the acceleration due to gravity at the depth d. So WD will be equal to W into 1 minus D by R. Then it's given the question that D is equal to R by 4, which implies that D by R equals to 1 by 4. From here on you will do the question yourself. Question number 31 देख लें बेटा आप. Question number 31 is reason assertion type question. तो question है क्या? सबसे पहले आप देख लें बेटा assertion. A simple pendulum is taken to a planet of mass and radius 4 times and 2 times respectively that of the earth. The time period of the pendulum remains same on the earth and that on the planet. The time period of the pendulum remains the same on earth and on that planet. तो पहले आपको देखना है बेटा whether it is true or it is false. Let's try to cross check that. Okay, so first of all, what about this acceleration due to, what about the time period? The time period is, you know that it is proportional to 1 by under root of G, isn't it? Then you know the acceleration due to gravity in terms of mass and radius. Acceleration due to gravity is proportional to m divided by r square. Now see the question. What is given in the question is that the mass of that planet is 4 times and the radius is 2 times. So the mass is 4 times, this mass is 4 times, and the radius is 2 times, and 2 square is also equal to 4, which implies that the acceleration due to gravity on that planet will be exactly same as that of the acceleration due to gravity on the earth, simply because this mass is 2 times mass of the planet, and mass is 4 times, and radius is 2 times, 2 square is 4, so obviously 4 divided by 4 will cancel, so the acceleration due to gravity will stay same, which implies that the first statement जो इसका पहला statement है वो correct है, that's true. फिर रीजन क्या दिया गया है? द मास ऑफ द पेंडुलम रिमेन्स अनचेंज्ड एट अर्थ एंड अदर प्लैनेट, ओके, which is completely incorrect, because acceleration due to gravity on the 2 different planets can change, and as a result of which the time period will change, but the mass of the simple pendulum, that will always stay same, whether the acceleration due to gravity on the 2 different planets is different or that is same, the mass is not going to change, which implies that the second statement is incorrect. So that means that assertion is true but reason is false. So iska jo correct answer hai beta, that is option number B. Now this question, we have just done this question, so this question I will keep this question as a home assignment for you. Question number 32. नेक्स्ट हमारे पास बेटा फिर से है स्टेटमेंट टाइप क्वेश्चन. अगेन इट इज एक्सेलरेशन ड्यू टू ग्रेविटी हैज़ टू डू समथिंग विद द सिंपल पेंडुलम, सॉरी इट इज सैटेलाइट रादर. ओके, तो देख लें बेटा आप क्वेश्चन है क्या. तो क्वेश्चन में पहला स्टेटमेंट ये दिया है: सैटेलाइट इज मूविंग अराउंड द अर्थ इन ऑर्बिट वेरी क्लोज टू अर्थ सरफेस. द टाइम पीरियड ऑफ द revolution of the satellite depends on the density of the earth. Okay, then next is that the time period of the revolution of the satellite is this. For a satellite very close to earth's surface, and where g is the acceleration due to gravity. First and foremost जो इसका दूसरा statement है that's correct. This time period of a satellite that is revolving around the earth close to earth is this, that is this जो यहाँ पे दिया गया है, this one. So that means this statement is exactly correct. This statement is exactly correct. Okay. And what about the statement first? A satellite is moving around the earth in an orbit very close to the earth's surface. The time period of the revolution of the satellite depends upon the density. Let's check that out. तो फर्स्ट एंड फॉरमोस्ट यू नो दैट द टाइम पीरियड जो है दैट इज प्रोपोर्शनल टू 1/√g. This time period depends upon acceleration due to gravity, isn't it? And we know that acceleration due to gravity in turn depends upon the density. How it depends upon density? Acceleration due to gravity is something like this: 4/3 pi into g into rho multiplied by r, which means that this time period depends on, rather it is inversely proportional to density of the earth. तो पहला स्टेटमेंट क्या है? सैटेलाइट इज मूविंग अराउंड द अर्थ इन एन ऑर्बिट वेरी क्लोज टू अर्थ सरफेस. द टाइम पीरियड ऑफ revolution depends on density of earth. So that means first statement is correct and second statement is also correct. So both the statements are true. Both first and second statements are true. Both are true. So the option number second is the correct. Okay. Let's move to another question, my dear students. Next question जो हमारे पास है that is again based on this acceleration due to gravity with the height h. What is the question? When one moves from point 16 kilometers below the earth's surface to a point 16 kilometers above the earth's surface, the change in g is approximately this. देख ले बेटा, first and foremost let's write down what is the value of gh, that is g into 1 minus 2h by r, because it is given that h is 16 kilometers, which is very small compared to r. So I can write down this equation. Now what the value will be? It will be g multiplied by 1 minus 2 into 16 divided by what's the radius? That is something like the 6400 kilometers. All right, let's calculate the value here. Gh will be equal to g into 1 minus, this is here 32 divided by 6400, isn't it? It will be g multiplied by 1 minus 32 into 1 divided by 2, तो ये आ जाएगा बेटा 1/200. Okay, so gh will be finally equal to g into 200 into 1 is 200 minus 1 is 199 divided by 200. This is acceleration due to gravity at height h. What about the acceleration due to gravity at depth d? That will be g into 1 minus d by r. ये आ जाएगा बेटा g multiplied by 1 minus. तो यहाँ जो वैल्यू आएगा, दिस 10 and 10 will cancel, it will be obviously 199 divided by 20. And here it is, d is 16 kilometers, r is 6400 kilometers. It will come out to be g multiplied by 1 minus 1/400, isn't it? So that means gd जो आएगा बेटा acceleration due to gravity at depth d, वो आ जाएगा 400 minus 1 is 399 divided by 400. 10 and 10 will cancel, it will come out to be 399 divided by 40. So next what we have to calculate is that the percentage change. Let's do one thing here. यहाँ पे ध्यान रखिए बेटा. Let's do one thing here. What is now gh and what is now gd? So gd is equal to 399 divided by 40, and what about this gh? Gh is something like this. It is equal to 199 divided by 20. Now we'll have to find the difference between these two. What's the difference of the acceleration due to gravity? Okay, तो क्वेश्चन फिर से आप देख लें बेटा. क्वेश्चन जो है that is the surface when one moves from 16 kilometers below to 16 kilometers above. That means we'll have to calculate gd minus gh. So it will be gd minus gh. देख ले बेटा, this will come out to be 399 divided by 40 minus 199 divided by 20. Okay, then divided by what? Divided by, I will write down here, divided by g original. What is that? That is gd. So divided by gd initial value. तो gd का वैल्यू क्या है बेटा? That is 399 divided by 40. तो ये आ जाएगा exactly, this will be here 1 minus, this is here 199 divided by 20 multiplied by 40 divided by 399. So this is 2's are, तो ये जो आएगा बेटा this is 399 minus this here 200 into is 400. This will be 398 divided by something like 399, which will eventually come out to be 1 divided by 399. I will multiply by 100 divided by 399%. So almost 100 divided by 400, which is 1/4. 1/4 जो आएगा बेटा, that is approximately it is 1/4, which is 2, this is here 1 by 4, so that is 0.25, and this is 1 by 4%, which is equal to 0.25% will be the answer to this question. Okay, calculation थोड़ी lengthy थी इसमें, no doubt about that, but I am sure that you got this question exactly. Okay, so let's move to another question. तो नेक्स्ट क्वेश्चन जो है बेटा, दैट्स परसेंटेज डिक्रीज इन द वेट ऑफ ए रॉकेट व्हेन टेकन टू हाइट 32 kilometers above the surface of earth. We'll have to calculate what's the acceleration due to gravity. Let's first of all do that. Gh will be equal to g into 1 minus 2h divided by r. Now gh will be equal to what? It will be g multiplied by 1 minus 2 into 32 is 64 divided by 6400. All right, so this is 1 by 100, so it will come out to be g multiplied by what? It is 1, this is 100, so it is g into 1 minus 1 by 100. It will be equal to what? It will be equal to 99 divided by 100, so it is equal to 99%. So that means of g, which implies gh is equal to 99% of g. When it is 99% of g, it implies that acceleration due to gravity decreases by 1%. Okay, final acceleration due to gravity is 99% of the initial acceleration due to gravity, which implies that it has got decreased by 1%. Let's move to question number 37. So question number 37 ये है कि यहाँ पे weight of the body is given on the surface of earth, that is 18 Newton at a height which is equal to 3200 kilometers. This 3200 kilometers is nothing but it is r divided by 2. We will have to calculate the weight. WH equal to W into r square divided by r plus h whole square. Just put the value here and get the answer from here, from the using this formula. तो क्वेश्चन नंबर 38 आप देख लें बेटा. क्वेश्चन नंबर 38 इज स्टेटमेंट टाइप. तो पहले आप देख ले बेटा स्टेटमेंट फर्स्ट. एक्सेलरेशन ड्यू टू ग्रेविटी डिक्रीजेस एज यू मूव अप एंड डाउन, सो इट इज ट्रू, नो डाउट अबाउट दैट. Acceleration due to gravity is same at height h and depth d from the earth's surface if h is equal to d, which is absolutely incorrect, because acceleration due to gravity decreases with height, it decreases with depth, but the rate of decrease of acceleration due to gravity with height and with depth is not same. It is twice with height compared to that with the depth, which implies that the first statement is correct, but the second statement is incorrect. Hence the answer to this question is that statement first is correct and statement second is incorrect. Question number 39. Next question जो है बेटा, that is again based on the simple pendulum. Let me keep this as home assignment for you because we have done these types of questions already. Let's move to another question. तो और एक क्वेश्चन फिर से बेटा, simple pendulum. Time period simple pendulum on the earth's surface is t. Its time period becomes xt when taken to a height r equal to that of the radius of the earth. So simple, it's very simple. First and foremost, let's calculate the acceleration due to gravity at height h. H is given r. gh will be directly equal to g divided by n plus 1 whole square. यहाँ पे जो n का value है that is 1, which means that it is g divided by 4. So the time period is proportional to 1 by root of g, which implies that this time period at height h divided by time period t will be equal to square root of g by gh. ठीक है जी. So that will be equal to square root of g divided by what is gh, that's g divided by 4. This g and g will cancel. Square root of 4 is 2, which implies th जो है that's equal to 2 times t. So the x value of x is simply that's equal to 2. Another question we have is this one, that's at a certain depth. तो देख ले बेटा क्वेश्चन क्या है. At a certain depth d below the surface of earth, the value of acceleration due to gravity becomes 4 times its value at height 3r. Okay, then what's this depth d equal to? Let's first of all write down that the acceleration due to gravity h दिया गया बेटा, that's equal to 3r. So that means gh जो है that is equal to g divided by n plus 1 whole square, which is g divided by 3 plus 1 is 4 square is 16. All right. then what is given is that GD. तो क्वेश्चन क्या है बेटा, फिर से क्वेश्चन पढ़ लेते हैं. एट सर्टेन डेप्थ D below the surface of earth, the value of acceleration due to gravity becomes 4 times. So that means this GD, which is equal to G into 1 minus D by R, it is already given that this acceleration due to gravity GD is 4 times GH, equal to G into 1 minus D by R. And already we have calculated GH. What is that? That is G by 16. So 4 into G divided by 16 equal to G into 1 minus D by R. Alright, which means that this equation will be here. G and G will cancel. This is here. 1 by 4 equals to 1 minus D by R. D by R will be equal to what? It will be 1 minus 1 by 4. And what is this 1 by 4? It is 3 divided by 4. So eventually this depth comes out to be, it comes out to be what? It comes out to be 3R divided by 4. Sahi hai na beta? Let's put the value of R here. What is the value of R? That is 6400 kilometers. You know that. So that means 4 into 16 is 64. 3 into 16 is 48. So answer will be 4800 kilometers. Is there any option? Yes, there is. Option number D. Again, a beautiful question, but I hope that this is again crystal clear to you. Okay? Take a G. You keep on doing the questions on the gravitation, ideas will pop out, and that's what's actually the primary purpose of solving the questions. So next is that question number 42. Ab dekh le beta, a body of weight W is projected vertically upwards from the Earth's surface to reach a height above the surface which is equal to 9 times. That means H is given, that's equal to 9 times R. So can you tell me what will be GH? That will be obviously G divided by n plus 1 whole square. The coefficient of R is n, that is 9. 9 plus 1 is 10. So ye ban jayega beta G by 10 square is G by 100, isn't it? Which implies WH will be straight away equal to W divided by 100. Hence this is the answer to this question. Question number 43 is a statement type question, easy question. I will keep this question as a home assignment for you, because there should be some questions which you need to solve. The weight of the body on the surface of Earth is 100. The gravitational force on it when taken to a height from the surface of Earth equal to 1/4. H is given, that's equal to R divided by 4. You will have to calculate what is WH. I will write down it's equal to WR square divided by R plus H whole square. From here on you will do this question yourself, because we have done a good number of questions on this pattern. So next question आप देख ले बेटा. Assuming that Earth to be a sphere of uniform mass density, great. Weight of a body at depth D equal to R by 2 from the Earth. If its weight on the surface of Earth is, again, what we'll have to use is that GD equals to G into 1 minus D by R, which means instead of acceleration due to gravity, we can write down the weight as well. WD equal to W into 1 minus D by R. D is given, that's equal to R by 2, which implies D by R is 1 by 2. So put it here, and W is given to you, that is 200. So easily this question can be done from here on. तो क्वेश्चन नंबर 49 देख लें बेटा. क्वेश्चन नंबर 49 क्या है? क्वेश्चन कुछ ऐसे हैं. A body weighs 49 Newton on spring balance at North Pole. Great, perfect. What will be its weight recorded on the same weighing machine if it is shifted to the equator? Will it be 49? Will it be greater than 49, or will it be less than 49? Okay, one thing is for sure, that is as you move, देख ले बेटा, जो earth है we assume that it's a perfect sphere, but essentially it is not a perfect sphere. It is something what you call as ellipsoidal. It is something like this. Okay, it is something like this. Now this is what we call as the polar radius, and this is what we call as the equatorial radius. Equatorial radius is greater than the polar radius, isn't it? Which implies that the acceleration due to gravity at the equator will be always less than the acceleration due to gravity at the poles. Okay, now it is given that the weight of the body on poles, on the North Pole, is 49 Newton. 49 Newton, which implies that the weight is the weight on the poles. So the weight on equator has to be less than the weight on the poles. तो अब इनमें से आपको directly you'll have to make an educated guess Which of the following can be the answers? 49 तो इसका आंसर नहीं होगा, it will be less than 49. 49.83 is not less than 49. 49.17 is not less than 49. 48.83 is less than 49. So without making any calculation, it's just a conceptual question. तो ये इसका आंसर है. और एक क्वेश्चन देख ले बेटा आप, that is consider a planet in some solar system which has mass double the mass of the earth and density equal to the average density of the earth. If the weight of the body on the earth is W, then the weight of the same object on that planet, what is which has mass double? Okay, एक तो mass double दिया गया and density is equal to. एक बात आप याद रख लें बेटा, if for example mass is constant, if mass is constant, then acceleration due to gravity is directly proportional to rho raised to the power 1/3. ये आप याद रखेंगे बेटा. ओके, एक्सेलरेशन ड्यू टू ग्रेविटी इज दिस. ठीक है जी, आपको ऑलरेडी पता है एक्सेलरेशन ड्यू टू ग्रेविटी इज प्रोपोर्शनल m/r². एक्सेलरेशन ड्यू टू ग्रेविटी इज प्रोपोर्शनल ρ मल्टीप्लाइड बाय r. लेकिन यहाँ पे इस क्वेश्चन में बात हो रही है मास और डेंसिटी की. देयर इज वन मोर इक्वेशन, दैट इज एक्सेलरेशन ड्यू टू ग्रेविटी इज डायरेक्टली प्रोपोर्शनल m raised power 2/3 ρ raised power 1/3. Now it is given in the question that the mass is constant, which implies that acceleration due to gravity is directly proportional to rho raised power 1/3. ठीक है जी. तो अब क्वेश्चन में क्या दिया गया है, इफ द वेट ऑफ द ऑब्जेक्ट इज W, द वेट ऑन दैट प्लेनेट हुज डेंसिटी इज, डेंसिटी क्या है बेटा, मास तो सेम है, सॉरी मास इज डबल, मास इज डबल. वेट अ मोमेंट, it is something like this, mass is 1/3 and density 2/3. Okay, so here it is actually not density 2/3, it is here directly proportional to mass 1/3. Okay, now it is given that the mass of the planet is 2 times the mass of the earth, which implies acceleration due to gravity on that planet will be equal to 2 raised to the power 1/3 the acceleration due to gravity on the surface of earth, and hence weight on that planet will be 2 raised power 1/3 into this. So this is the answer to this question. Okay, so we are done with the questions on this topic, which was variation of acceleration due to gravity with height and with depth, and we have done a good number of questions on this. तो नेक्स्ट क्वेश्चन जो है बेटा वो ये है कि हाउ एक्सेलरेशन ड्यू टू ग्रेविटी वेरीज विद द डिस्टेंस फ्रॉम द सेंटर ऑफ द अर्थ. नाउ हैव a look, my dear students. This is what we call as, this is for example earth, all right. This is the center of the earth. तो यहाँ से यहाँ मैं एक लाइन डालता हूँ बेटा, which we call as the radius of the earth, and the mass of the earth that's equal to m. All right. Okay, so the first thing I will write down is that at the center of the earth, what is acceleration due to gravity? At the center of earth, acceleration due to gravity is exactly equal to 0. Okay, the next I will write down on the surface, what is the acceleration due to gravity on the surface? On the surface, you know that acceleration due to gravity is maximum, which comes out to be gm divided by r², isn't it? Which is the maximum value of acceleration due to gravity. So what will be the acceleration due to gravity inside? But just apply your common sense. Tell me one thing. As you move from the center of earth to the surface of earth, does the acceleration due to gravity increases, decreases, or it remains constant? It's obvious that acceleration due to gravity increases as you move from the center to the surface. So when it increases, I will write like this, it is directly proportional to r, isn't it? Which implies that acceleration due to gravity will be something like this. It will be gm multiplied by r divided by capital R² की जगह मैं लिखूंगा बेटा capital R³. So that on the surface of earth, यहाँ पे ध्यान रखिए बेटा, on the surface of earth, the small r becomes equal to capital R, and one capital R will cancel, it will be gm by r². And what will be the acceleration due to gravity outside the earth? What's acceleration due to gravity? You know that as we move away from the surface of earth, the acceleration due to gravity keeps on decreasing, which implies that acceleration due to gravity outside, so this is inside. Outside, it is inversely proportional to r². r square, which implies that the acceleration due to gravity outside will be something like this. It will be gm divided by small r square. So at the center of the earth, what is acceleration due to gravity? 0. On the surface of earth, acceleration due to gravity is gm by capital R square. Inside, acceleration due to gravity is gm into small r divided by capital R cube. And outside acceleration due to gravity is equal to gm by small r square. All right, हमने यहाँ पे ये प्रूव नहीं किया है. We have not proved this equation. We'll prove this equation using what we call as Gauss's law in electrostatics. But I hope that without proof this is even crystal clear to you. Okay, let me again write down in a single line that acceleration due to gravity at the center is equal to 0. Acceleration due to gravity on the surface is gm by r square, which is maximum. Acceleration due to gravity outside is gm by small r square, because it's inversely proportional r square. And inside it's directly proportional, so I will write like this: gm into small r divided by capital R cube. All right, my dear students. So what about the graph? Let me write down here one more important point, and that is plot acceleration due to gravity versus r. This r is the radial distance from the center of earth graph, which is very, very important graph, and so many times this graph will be repeated. That we will have to plot the acceleration due to gravity versus the radial distance, that is r graph. So let's try to do that. Let's try to plot this graph. ठीक है बेटा, let's try to plot this graph. First and foremost, I will write down this is small r equal to 0. Okay, this is small r equal to capital R, which is the surface. So that means this is small r greater than capital R, it's outside. This is small r less than capital R, which is inside. Isn't it? Is this clear, beta? Is this clear to you? Okay, so tell me one thing. What is the value of this acceleration due to gravity at the center? What is the value of acceleration due to gravity at the center? That is what? That is 0. As you move from center to surface, the value of acceleration due to gravity will increases. So this is the graph which implies g is directly proportional to r. It is maximum on the surface of earth. Then outside it is inversely proportional r square, which implies the graph will be what you call as the rectangular hyperbola. So this is what you call as rectangular hyperbola. So outside acceleration due to gravity will be proportional to 1 by r square. Okay, and on the surface of earth, acceleration due to gravity is exactly gm by r square, which is the maximum value of acceleration due to gravity. And this graph has been so many times asked in NEET and JEE. So many times this graph has been repeated and will be repeated again in electrostatics, in magnetism later on. Okay, I think we should stop here. So see you in the lecture number 5. Take care.